here are list some key APIs that we provided through Twister. So the top section is about configuration. So we set up the configuration of map task and the reduce task. The middle part is mainly about the broadcast, because we know iterative function have to broadcast global data. And the lower part is a detailed kind of functions that you can call map and reduce interface. So this architecture actually illustrates very well from the system perspective how to understand the iterative MapReduce, specifically Twister. From lower level, you can see that there's storage. It's about data. It's the file system are distributed. You can distribute your data across the local disks. And a level up is linked to the cache, because distributed system at the runtime is distributed cache. And then you can look at the iteration part. It's the control flow of the whole runtime systems. From column-wise, you can see this kind of scheduling. You schedule map and task, and then as a daemon to spawn all these kind of functions. And in between this different kind of map and reduce task, you use a pub/sub messaging system to do control flow, small messages. On the other hand, we have another layers communication service. We do data transfer. So this whole architecture basically illustrates every component needed to consider in a distributed environment. So we mentioned about the data storage and the caching. So we have several levels of abstractions here. And this illustrates that we provide the tools to allow you to, at the very beginning, distribute data across the disks. And I will give you examples. And this data is being partitioned as partition file, which is a metadata to show that the chunks will be stored on which path. And pub/sub messaging, we currently use ActiveMQ and Narada broking. And broadcasting has a different kind of interface, and we optimize highly data transfer. And this is one example to illustrate how we do that. If you do broadcast sequentially, it's very time consuming. So we highly parallelize all these kind of intermediate communications. And this actually illustrates well that's how we need to optimize the performance and in between each iteration based on the communication layer. And another thing is that we're looking into using InfiniBand to accelerate the data transfer. And this is actually a factor of 4 faster than normal Ethernet. So any MapReduce system will claim that they're fault tolerant. So that is a feature we must support. With that, I give you a demo about Twister-MDS. So this is the background of why we do this. So usually, as the speakers from the first day, Michael Schatz said, bioinformatics has need a lot of processing pipelines. So you can see from this chart, from gene sequencing to pairwise clustering to dimension reduction to visualization, this is the pipeline. There are a lot of complex pipelines in processing bioinformatics data. So we actually have a million sequence challenge problem. So we have the input data side is less than a million, but we have a very large data set. And then we process them, try to clustering them, dimension reduction, and visualize that. And so this snapshot shows the visualization result, and you can clearly see the structure of this data. Without this kind of a process, it's very difficult for human beings to look at the raw data and browsing the sequence space. So this is underpinned by a very powerful algorithm we developed in-house. It's called dimension reduction algorithm. We have two of them, but the one I'm going to demo is that MDS. This basically try to, using the chi-square fit algorithm, and parallelize that and optimize. So you can see the snapshot to see the result of dimension reduction. So on the left-hand side, this is a 100,000 PubChem data set. The challenge of this kind of program is that because the time complexity, both time complexity and the size of the data is very challenging, and then it's all over n squared. So if you have 100 data points, that n squared is 10,000. It's not a big deal. But if the data size is 1 million data points, then ultimately your processing is 1 million squared. That is very time consuming, and yet sometimes it's not possible to finish. So that's why we have a variety of optimization to do that. With that algorithm being running on the clusters using Twister, and we can timely generate all those results of dimension reduction, and we're using the middleware system to transfer the data to a local visualization tool and called plotviz. And this actually, the demo is using 30,000 metagenomics data, and we'll show you this demo. So there are several steps. Initially, we started the ActiveMQ middleware messaging systems. And then now the system is trying to, the next step is starting the Twister runtime systems. All right. The third step is that we need to load the data. So before we do that, we distribute the data. This is distribution of the data. So after the distribution, all the data chunks go into different kind of nodes. So next step is that we want to load the data to the local cache or memory. So this requires that we generated the partition file. So next step, that map tasks know which data chunk to load into the map tasks. Now we can start the Twister processing. So after it starts, and then they process data in each map task, and then keep generating the result at each iteration. The partial result or intermediate result will be broadcast or transferred through the middleware system to the client tools of visualization, and you can see that the whole process of iteration and refinement of the dimension reductions. So initially, this data set is 30,000 genomics data is kind of like a mess. And then with each iteration refinement, you can see the data structure is getting clearer and clearer. So at the end of the iterations, you can find that clearly there are clusters at different levels, and we're colored by different colors. So you can see that clearly there are some green clusters. There are red clusters. You can see the structures, they're very distinctive.